Hello and welcome to another NGen Math 8 lesson by eMathInstruction. My name is Kirk Weiler and today we're going to be doing Unit 3, Lesson 4, Reflections in the Coordinate Plane. A couple lessons ago we actually did some reflections, but back then it was in the Euclidean plane, and in order to do them we had to trace out our image on a piece of tracing paper along with the line of reflection and then sort of fold that over the line of reflection and retrace out. Now that was good stuff, because we learned a lot about reflections, including one of their fundamental properties, that when we connect a point with its pre-image, or an image point with its pre-image, then what happens to that line segment is that it is perpendicularly bisected by the line of reflection. And we're going to see that again today, in fact, in the first exercise. So let's jump right into it, where we start to look at reflections now in the coordinate plane, where we've got the x and the y axis to help us out. Let's take a look in exercise number 1. All right, here we go. Exercise number 1. Triangle ABC is shown plotted on the grid below. Its vertices have coordinates at A, 5, 8, B, 7, 3, and C, 2, 4. Letter A asks us to reflect triangle ABC across the y-axis, label its image triangle A', B', C'. Show where each of the three vertices get mapped below. All right, so this is simple enough, especially to visualize. The whole idea here is that we've got this triangle plotted in the first quadrant. The idea would be now if we took our paper and we literally folded it along the y-axis and then we traced out our triangle again, where would it go? Well, it's a pretty easy thing to visualize, right? Because the idea is that A, if folded over, right, A here is at -5, 8, and if folded over, it would land on -5, +8. Right? Let's actually write that down right away. So A would get mapped to A prime at -5, 8. Right? It'd be right here. Or something. There we go. Kind of. Oh, nope. I'm just not going to get my A. There it is. A prime. All right. And likewise, right, here B at 7, 3, if we folded it over, would be over here at -7, 3. -7, 3. So let's write that down, B prime, -7, 3, and let's plot it right there. All right. And finally, of course, we've got C at 2, 4, right? If we folded it over, it would be over here at -2, 4. And let me get that negative sign there a little bit better. -2, 4. I'm going to just connect these things by freehand. You should likely use a straight edge just to make it look really good. Now, just a little side note, right? We could have called this a fold or a flip. We technically call it a reflection, right? And the reason why is that literally, if the y-axis was a mirror, right, then this would be the image of this triangle in that mirror, right, where everything kind of gets a little reversed, so to speak. Now let's take a look at letter B, right? I'm going to bring this just up a little bit. Letter B asks us to connect each vertex of triangle ABC with its image point using a line segment. What is the relationship between these line segments and the y-axis, the line of reflection? All right, well first, let's just kind of really quickly freehand and connect each pre-image point with its image point using a line segment, right? So in other words, let me connect that, and that, right? Now, the second part of letter B just, the first part is just draw those line segments. The second part is, what is the relationship between those three line segments that I just drew and the y-axis, right? What is their special relationship? See if you can remember this from a couple lessons ago. Well, the relationship is that the y-axis is the perpendicular bisector of those three segments. Let me write that down really quick. A very important term. So the y-axis is the perpendicular bisector of the three segments. All right. We can tell that it's perpendicular simply because the three line segments are all horizontal and the y-axis is vertical, and all vertical lines are perpendicular to all horizontal lines. But we can also tell it's the perpendicular bisector. In other words, it's a bisector because if I looked at each one of the intersection points between those segments and the y-axis, what I'd see is each one of those points is the midpoint of that overall segment. So that's 5 units, that's 5 units. 2 units, 2 units. 7 units, 7 units. And again, that's the whole idea of a reflection, right? Is the idea that a point, a pre-image point, once it's reflected, would lie the same distance away from the line of reflection as the original point, right? And how we measure that distance the point is away is by drawing a perpendicular line, right? We're not like drawing a line from here down to here. It's not like it's a slanted line and then we slant reflect or something like that. Nope. We are literally reflecting it in a perpendicular sense across that line so that it lands the same distance on one side of the line as it started on the other. Now, let's take a look at another reflection, but maybe reflect across the x-axis instead of the y. Take a look at that in letter C. Now here, I've reproduced the graph, right? So you've only got the one sheet, but here I wanted to have a clean sheet. Let's take a look at letter C. Reflect triangle ABC across the x-axis. Label its image triangle A double prime, B double prime, C double prime. Show where each of the three vertices gets mapped below. All right, well, see if you can use what we did in letter A to do exactly the same thing, except instead of flipping this triangle across the y-axis, you're going to take this triangle and flip it across the x-axis. Go ahead and pause the video and take a few minutes to do that. All right, well, here we go, right? If I took point A at 5, 8 and I flipped it down, it would end up at 5, negative 8. So A double prime is 5, negative 8, which is right down here, right? B double prime, well, here, we're out here at 7, 3. If I reflect across, we'll be at 7, negative 3. So B double prime, 7, negative 3. And likewise, that C double prime is going to be at 2, negative 4. What you might notice is that what I did was I ended up just changing the sign on all the y coordinates. It's very similar to letter A, right? All of those positive y's suddenly became negative y's when I flipped it across the x-axis. Okay? Let's take a look at that last piece of this problem. What happens when points are reflected over the x and y axes? Describe what happens to the coordinate points in both cases. All right? So what exactly is the rule, right? So what I'd like you to do is pause the video now and think if you can give a succinct rule or description of what to do when we take a point and we reflect it across the y-axis and what happens when we reflect it across the x-axis. Pause and think about this problem a bit. All right, well, it's pretty much this simple, right? Let's go back up here. Right, when we were reflecting across the y-axis, 5, 8 became negative 5, 8. 7, 3 became negative 7, 3. 2, 4 became negative 2, 4. And notice what happened in each case when we reflected across the y-axis. The x-coordinate changed its sign, but the y-coordinate stayed the same. On the other hand, when we reflected across the x-axis, 5, 8 became 5, negative 8. 7, 3, 7, negative 3. So when we reflected across the x-axis, the y-coordinate changed its sign, and the x-coordinate didn't change at all. So we can really summarize this by saying, okay, in terms of the y-axis, right, we are going to change the sign of the x-coordinate. In symbolic form, and this is good to write down, we would say that the point x comma y gets mapped to, that arrow means gets mapped to, negative x comma y. All right, so this rule just says, hey, look, if I'm going to reflect across the y-axis, take the point x comma y, take whatever the x-coordinate is and negate it. That means if it was positive, it becomes negative, and if it was negative, it becomes positive, but the y-coordinate, don't change that at all. And likewise, very, very similar, right? Let me extend the page a little bit so we've got some room to work. If we reflect in the x-axis, we're going to change the sign of the y-coordinate. And again, in terms of a rule, that would be x comma y will get mapped to x comma negative y. All right, it's that simple. Let's take a look at this in the next exercise. Here we go, exercise number 2. Trapezoid MNPQ is graphed on the grid. Letter A, trapezoids must have at least one pair of parallel sides. Which two sides of MNPQ are parallel? All right, this should take you very little time. Pause the video right now and tell me which two sides of that trapezoid are parallel to one another. All right, well, this is simple enough, right? It's these two sides. I'm going to circle them, then I'll erase. But we've got side MQ with a bar on top and NP. By the way, if you needed to give a reason, you could say, well, they're both vertical, right? They're both vertical. All vertical lines are parallel to each other, so if I've got two line segments that are both vertical, then they're parallel to each other. Now, letter B, let's get into some reflection work. Draw the image of MNPQ after a reflection in the y-axis, Label its image M prime, N prime, P prime, Q prime. State the coordinates of the image's vertices below. Awesome, it should be easy enough. I'd like you to take that image and I'd like you to reflect it in the y-axis, see where it goes. I'm going to just erase this stuff really quick. And then let's also talk about where the coordinates went. Pause the video now and reflect this thing across the y-axis. All right, well, let's just go through it point by point. Here we've got M, and it's at negative 2, 5. So if I reflect it across the y-axis, it's going to be at 2, 5. So I'm going to write these things down as I go. M prime is going to be at 2, 5, which is going to be right here. All right, let's go with N prime next. Right, currently N prime is at 6, 9, so 6, 9. When we reflect it across the y-axis, it's going to be at negative 6, 9, right? All we're doing is changing the x-coordinate or the sign of the x-coordinate. All right, let's keep going. So P is going to be at 6, negative 2. When I reflect it, it's going to be over here at negative 6, negative 2. So P prime, negative 6, negative 2. And finally, what do we have? P prime, N, M, P, we got Q. So finally Q, which is at negative 2, positive 2, when I reflect it over, it's going to be at positive 2, positive 2. Just couldn't see what my last point was. Positive 2, positive 2. Now, I want to connect those with straight line segments to finish off my image. And a nice dead spot right there. All right. And I've got that trapezoid. All right. Couple follow-up questions. Let's take a look. Letter C. Are the images of the parallel sides from A still parallel in the reflection? All right. Sorry, I forgot to label a point up here. So, there's no guarantee that when we transform two parallel line segments that their images will also be parallel. Are they in this case? Pause the video and think about this for a moment. All right, and the answer is yes, sure they are. N prime P prime is here, M prime Q prime is here. They're both still vertical, so they're both still parallel. So yes, both are vertical. So parallel. Awesome. Now the final one, which may be the trickiest, right? Letter D. There were 2 points that didn't change location on M, N, P, Q when it was reflected. Where are they? Circle them. All right, and by where are they, let's circle them and let's also state their coordinates. There were 2 points that are what are known as invariant. That's not a term that you need to know, but literally when we reflected this trapezoid across the y-axis, these points didn't go anywhere. Which 2 points are them? Which 2 points are they? Circle them, pause the video, see if you can figure this out. All right, well, it's pretty much simple. It's this point and this point, right? These points didn't go anywhere. The points 0, 6 and 0, 1. And the reason that those 2 points didn't go anywhere is that they lie on the line of reflection, right? And since you're always taking points and moving them the same distance away from the line of reflection as where they started, any point that's on the line of reflection will not go anywhere. It's literally 0 distance away from the line of reflection, and so after being reflected, it should continue to be 0 distance away from the line of reflection. So any points that lie on the line of reflection, when reflected, stay there. All right, let's kind of keep going. Let's see what we got on tap next. All right, reflecting and other horizontal and vertical lines. As you might recall in the last lesson, we looked at horizontal and vertical lines, lines that have equations like y equals a number or x equals a number. Well, we can actually be asked to reflect geometric objects in other horizontal or vertical lines. So the y-axis is a vertical line. The x-axis is a horizontal line, but we can be asked to reflect in other ones. So let's play around with that a little bit in the next exercise. Exercise number 3. Right triangle EFG shown below is going to be reflected in the line y equals 3 to produce the image triangle E prime, F prime, G prime. Letter A simply asks, what type of line is y equals 3, horizontal or vertical? Well, hopefully, after the last lesson, you're comfortable that y equals a number is a horizontal line. All right. Letter B asks us to do the obvious, which is to graph y equals 3 on the grid. What I'd like you to do is pause the video now and go ahead and do that, given the fact that we literally did a bunch of these in the last lesson. Now remember, if you're confused about it, all I want you to do, and I'm going to do this right now, is I want you to write down some points where y is equal to 3, all right? So in other words, maybe the point 0, 3, maybe the point 5, 3, perhaps the point -2, 3. All of those will lie on the line y equals 3 because, well, to put it mildly, all those points are points where y is equal to 3. So if I graph them, I very quickly see it's a horizontal line. I then graph my horizontal line, y equals 3, and I'm all set. All right, now for the important part, letter C. Reflect triangle EFG across y equals 3. State the coordinates of the image's vertices. Now, unlike reflecting in the y or the x-axis, where we could come up with some kind of simple rule like change the sign on the x-coordinate or change the sign on the y-coordinate, doing something like this literally just requires a little bit of counting, right? So for instance, if I was going to reflect the point E across the line y equals 3, I want it to be the same distance on the other side as where it started. Now E maybe wasn't the best point to start with, but E is only 1 unit away from y equals 3. So if I flip it across y equals 3, right, it's going to go from right here to right here, right? That's now going to be E prime, all right? What I'd like you to do is simply use counting to figure out how many units F and G are away from y equals 3, all right? And then put their image points the same distance on the other side of that line as where the pre-images started. Pause the video now and go ahead and do that. All right, well, if you simply do counting, and that's it, you can start here at F and you can go 1, 2, 3, 4, 5, 6. I believe F, yep, is 6 units below that line. So to figure out where F prime goes, we're just going to go 1, 2, 3, 4, 5, 6. All right, and it's going to be way up here. 1, 2, 3, 4, 5, 6, yes. Just had to make sure. G is 2 units below the line, so its image, G prime, will be 2 units above the line. And when we connect those with straight line segments, we end up getting that image. All right. We should also finish the problem as it says, which is to state the coordinates. Let me do that now. Bring the screen up just a little bit. We'll have E prime, and you got to be careful here, which is at -3, 4. It's very easy to look at that horizontal line and think that it's the x-axis or something like that. F prime is going to be at 7, 9. And let me put G prime down here. That is going to be at 9, 5. All right, and that's it. Pretty easy, right? The only thing that's more challenging about reflecting across a horizontal or vertical line that isn't the x or the y-axis is that you have to graph it first, and then you have to be careful about counting the distance that a given point is away from that horizontal or vertical line. Let's take a look at one last example that's got some horizontal vertical stuff going on in it in exercise number 4. Let's take a look. In the image shown, kite ABCD has been reflected across the line to produce kite, shouldn't say kit, kite A prime, B prime, C prime, D prime, or kit, you know, whatever. All right, so letter A asks us to draw the line of reflection. All right, so what I'd like you to do is I'd like you to kind of step back and think, you know, is the line of reflection horizontal? Is it vertical? If you can figure out which one of those, then the question becomes, can you figure out where to draw it, right? Then the final part in letter B will be to come up with its equation. I don't want you to worry about that so much right now, but see if you can pause the video right now and figure out how to draw the line of reflection. All right, well, it's easy enough in theory, right? I'm looking for some vertical line, hopefully you figured that out, some vertical line that when I fold this thing over that vertical line, this kite hits this kite, or you know, whatever we're gonna call it. Anyway, this kite lands on this kite. But how do I figure out the exact location of that vertical line? Well, one way to do it is to use the idea that that vertical line will be the perpendicular bisector of the segments that connect the points to their image points. Now, I'm not going to worry about point B and B prime, okay? But like if I take A and A prime, right? If I take these two and I connect them, all right, and I count, then what I will see is that there are 10 units between these two. So if I go 1, 2, 3, 4, 5, right, that's got to be the midpoint of that line segment. The line of reflection has to go through that point. Likewise, let's take a look at D and D prime and C prime really quick. So if I connected D and D prime, what I would notice is that that was 6 units here. So if I went just 3 units from both sides, that would be the midpoint. And likewise, C, right, to C prime, that's also 10 units, 1, 2, 3, 4, 5, and that would have to be the midpoint. So the line of reflection must go through that, and that, so I can now draw my line of reflection. Not the prettiest thing on earth, but there we have it, right? And that's really what I've been asked for in letter A. The question is, what's the equation of the line? Well, it's a vertical line. Okay, that's going to have x equals a number, right? X equals a number. And if you're wondering what number, you could actually read off the coordinates of all these points. This is -2, 2. This one is -2, 9. This one's at -2, 7. I don't know about you, but they all look like points where x is equal to -2. And therefore, that's its equation. All right? So not too bad. The key, though, again, is going back to this idea that the line of reflection must be the perpendicular bisector of these segments, which allows us to actually figure out where it should be plotted. All right, let's wrap this up. Now, the majority of the time that you do reflections in the coordinate plane, you're going to be flipping over the x-axis or the y-axis. And we even looked at some rules for how to do that, right? If we reflect an image or a point across the y-axis, we do that by simply changing the sign on the x-coordinate, leaving the y-coordinates alone. Likewise, if we reflect across the x-axis, we're going to change the coordinates, the signs of all the coordinates of the y, and we're going to leave the x alone, right? So that's easy enough, and people catch on to those very quickly. What's more challenging is if we have to reflect across other horizontal or vertical lines, because oftentimes it takes 2 things. 1, plotting the line itself if it's not there, and then 2, counting how far a given pre-image point is away from the line to then figure out where its image point should end up. All right? But again, it's all just counting, right, and being able to plot those lines. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.